Okay, guys, based on a couple requests, I want to just clear up a couple questions on the exam. I got a few requests from some students, so happy to just kind of go through each question and tell you what you'll need to do for them. Okay, so let's take a look at this first question here. So basically what's going on is that we have U.S. Department of Transportation data telling us that in America, households have an average of 1.97 vehicles in their household. So a mean of 1.97. And they take this sample of 650 people in the US with a degree in environmental sciences, believing that people with environmental science degrees would drive less. Well, not necessarily drive less, but be less likely to own cars. And then do this hypothesis test to see if there's a difference between the US population and this group of people with environmental science degrees. Okay. So when you're doing questions like this, always start with writing down your variables. I did this for you here in the question. So what's going to happen is you're always going to know of these 5 things. You got your sample mean, sample standard deviation, population mean, population standard deviation, and sample size. You're always going to know 4 of them. One of them you're not going to know. And that's going to determine whether you use a Z or a T test. So I kind of helped you out on the exam and put that I want a T distribution, but if you don't know your population standard deviation, you can't use the Z, you have to use the T. So let's go through what we have real quick. So we know the population mean, total number of cars. We don't know the population standard deviation. We know the sample mean. Well, there it is right there, so we know that. We know the sample standard deviation, and we know the sample size. So we don't know this. So if we don't know this, then we have to use the T distribution to compute a T test statistic. If we did know this, then we use a Z test statistic. Now, if you watch the original videos for the hypothesis testing lecture, it's kind of like point number 1 and point number 2. Point number 1, if you know the population standard deviation, you can use Z. If you don't know it, that's point 2, and you only know the sample standard deviation, you use T. Okay? So here are the things we know. So we got our population mean is 1.97. We've got a sample mean, sorry about that. That's not right, sorry. Okay, we have our population mean, 1.97. Our sample mean, we got 1.69, and a sample standard deviation of 0.18, and N is 650. Don't tell me I'm out of lead. $650, sorry. I hate pencils. Okay. So these are the things we know. So I'm going to let you kind of go on the assumptions. That should be okay. Those are directly in the slides. Please know the assumptions you have to make in order to do this testing. That should be pretty clear. Filling in the values for the following variables, that's easy too. That's just reading the question. That's just what I did here. Stating the null and research hypothesis is where things get a little, get into the real stuff. But we'll always have a null and a research hypothesis. And in cases where we're comparing keep in mind what we're doing here. We've got a big population, the US. We took this little sample of people with environmental science majors. We're comparing this sample mean to this population mean. That's essentially what's going on here. The null hypothesis is always going to be the same. It's just that our mu for environmental studies majors is going to equal 1.97. So it's the idea like, is this group, are they different than the overall population, or are they the same? The null hypothesis is that we always assume that there's no difference. Innocent until proven guilty. That was you're back from the previous videos, that was my analogy, the innocence thing. Now the null hypothesis is always going to be that they're equal, that they're not different. The research hypothesis is going to be that they are different, and it can be either less than, greater than, or not equal to. Remember, this is a 2-tailed test and a 1-tailed test. I again specifically ask for a one-tailed test. Why? Because I have a theoretical reason to believe that my environmental studies majors will have less vehicles than the average American. So my null hypothesis is going to be that the mu for environmental studies majors, it will be less than 1.97. And you could look at these numbers and say, well, 1.69 and 1.97, clearly that's less. But the question is it statistically significantly less? Remember, back to your estimation stuff, this is really a confidence interval. You know, when we include, I could ask you to calculate the confidence interval for this, and you could see, you know, what our estimation is, but we always have a point estimate bounded by a confidence interval dictated by the standard deviation. So the question is this number truly different and indicative of a different mean of a group? Or is it just driven by chance? Maybe we just happen to sample 650 people who were less likely to have cars. So is this a sampling error thing, or is it a true difference? That's all you're doing here. And that's what this says here, is that our null hypothesis, what we have to assume until we can prove it otherwise, is that it's not different, that we assume that the mean is equal to 1.97. But what we're testing to see is if this group mean is truly less than 1.97 as we believe. Okay? And then the rest of it's just computing the test statistic. Really, the math here is actually pretty basic. You know, here's your equation. So we want to, let's go back here and look. So we're using an alpha equals 0.05. So our, you know, we can look up our critical value using that in the book. But we have to first compute the test statistic. And that's just this equation here. So we're going to calculate T is equal to sample mean minus population mean. That's just going to be 1.69 minus 1.97 divided by a standard deviation, 0.18, over the square root of n, which is going to be 650. And I'll let you work that out. Now, you're going to get a T, so we refer to this, our calculation, we refer to it as a test statistic. In order to see if we reject our null or fail to reject our null, is we compare our test statistic to a critical value. Let's go to the T distribution in the book. And the first thing you have to do is determine whether you're doing a one or two-tailed test. In this case, it's a one-tailed test, and I wanted it an alpha of 0.05. So that's the 95% confidence interval. And again, like I had in the last video, we see all these degrees of freedom things on the side. You're gonna have to calculate that. That's really easy. It's just the sample size minus 1. So our degrees of freedom is literally just 650 minus 1, so 649. If you look in the book, it only goes up to 120, so we're going to use infinity. And at an alpha equals 0.05, we've got a critical value of 1.645. If your calculated T statistic is greater than that number, then you reject the null. You found significance. If it's less than this number, then you fail to reject the null. You accept the null. You can't say they're different. So just to go over that again, if this number that you look up in the book, well, I'm sorry, let's put it in terms of this number you calculated right here with the equation. If this number is greater than the number in the book, the critical value, then you accept the research. You reject the null because this is larger than the T in the book. If you calculate a test statistic and it's less than the T in the book, then you can't say they're different. Then you accept the null, or you fail to reject the null. And that's kind of it with that. So I'll go back to so here you'll determine, I calculate your test statistic is 6.45. I already found that for you, it's in the book, but it's not hard to find. If your calculated test statistic for T is greater than 1.645, then you reject your null. If it's less than, then you fail to reject, or you accept the null meaning, which is what you'll do here. You'll make your conclusion, and then you'll go back and write about what it is. So, what are you actually testing? You're testing the difference between that group of environmental studies majors and the overall population to see if they're truly different. Okay. So that's all for number 3. This is your, here's your equation right here. And now keep in mind too that if we could calculate a z critical value, but in that case we'd have to know the population standard deviation. So in this case we only know the sample standard deviation, so we use the t. We get a test statistic, we compare it to the critical value. That's all you're doing in all these. You calculate a test statistic and you compare it to the critical value. And you determine whether or not your hypothesis is true. Okay, so that's question 3.